All right, let's go through this check-in together. There's a lot of stuff here with significant figures, applying them in calculations, dimensional analysis, density. So, there's not a lot with each one. So we're going to need more practice, but at least it's a pretty good overview of a lot of different topics. So let's get started with state the number of significant digits. So in this first one, it's 1, 2, 3, 4. All of those are significant. And the second one, it's just 1. Now, as an aside, if it was written 1000 with a period after it, then it would have 4 significant digits. Or if you wanted to write the number 1000 with 2 significant digits, you would write it like this, because 1 times 10 to the third is 1000, but this is showing 2 significant digits. And then just to be thorough, the only other option, if we had 1.00 times 10 to the third, now we're showing that it has 3 significant digits. Okay, zeros after the decimal before a number are not significant. So this one only has 2. This number is pretty straightforward, 3. This number, pretty straightforward, 3. This one is only 1, 2. So zeros after a number after the decimal are significant. Okay, then it gets a little more tricky with rounding. So if I do in my calculator or my OneNote, 2.3 times 45.98, it's 105.754. But the way that it works with multiplication and division is this one has 2, this one has 4, so you always go with the smallest of the 2 numbers. That means my answer can only have 2 significant digits, and this 5 is going to kick this up. So the answer would be 110. Or you could write this 1.1 times 10 to the second. Either way, that would also show 2 significant digits. Okay, the next one, if I plug into my calculator 45.8 divided by 0.003, it comes out to be 15,266.6667. Well, this is 3 significant digits, and this one's only 1. So my answer can only have 1. So this 5 actually kicks that 1 up to a 2, and so it's 20,000. Because this has 1 significant digit. All right, and the last one, if I plug into my calculator 200.0 times 3.5, my calculator says 700. But this has 2 significant digits. So in order to write 700 to 2 significant digits, I need to write 7.0 times 10 to the second. Now I've written 700, but with 2 significant digits. So keep practicing on those. And also there's kind of a nice overview of the rules and the calculations with significant figures. Also, there's some great, YouTubes that you can just search up to give you more practice. Okay, dimensional analysis. One thing that I want to mention is when I have a conversion that's exact, such as 1 foot equals 12 inches, what that really means is an infinite amount of significant digits on the foot and an infinite number of significant digits on the inches. So we only really take the starting measurement and we go from that to determine how many significant digits our answer should have. So in this case, just as a preview, we're starting with 6.000 qubits. And that number has 1, 2, 3, 4 significant digits. That's our only measurement. That means our answer is going to have 4 significant digits. Now, I've got to get this into, what did it say? Meters. So I'm going to start with cubits into palms because I see that that is a conversion. 1 cubit equals 7 palms. Right away, I can slash out cubits. So I know that next I need to cancel out palms. Next, I've got 1 palm is equal to 4 fingers. Okay, so palms cancels out. I've used this conversion in this one. Next, I've got to get rid of the finger, so I'm going to write that on the bottom. Sounds funny. 1 finger equals 18.75 millimeters. Fingers cancels out. I've used that conversion. And last but not least, I want millimeters to cancel out on the bottom, and I want to end up with meters. So there are 1,000 millimeters in 1 meter. Now millimeters can cancel out. Now, when I plug this all into my calculator, you got to be careful to do this. Let me move this off. Oops. Let me see if I can move this out of the way to give us more space here. Go away. Okay, good enough. So in my calculator, I'm going to do 6.000, okay, times 7 times 4 times 18.75 times 1 divided by, on the bottom, 1 times 1 times 1 times 1,000. Okay, and when I put that in and then I do the top divided by the bottom, I get 3.15. But this is only 3 significant digits, so I have to add a 0 to show that I do know it to be that precise. Okay, next, Miss Baker races Dr. Leff and ends up winning after traveling in my car at a speed of 54 meters per 1 second. How fast was I going in miles per hour? Well, first of all, I want to also say, oops, this is 3 significant digits here, 54.5. So my answer, I'm going to be looking for 3. I'm going to start with getting rid of meters. There was a conversion up here, 1 meter, or 0.3048 meters is 1 foot. 0.3048 meters is equal to 1 foot. So meters are going to cancel out. And now I've got to get feet into miles. Okay, I saw 1 mile is 5,280 feet. Does everyone have that memorized? I feel like it's a thing. Maybe not. Maybe it's just nerdy me. Okay, so we've got miles on the top now. Come on, stylist, don't die on me now. Okay. Oh, why can't I? Okay, this is annoying. There we go. Now I've got miles on the top, and I want to get rid of seconds because I want to get this into miles per hour. So I know there are 60 seconds in 1 minute. So seconds cancels out. And I know there are 60 minutes in 1 hour. So minutes cancels out. And now I'm going to have miles per hour. Once I multiply everything across the top, I'm going to ignore the ones because they don't matter. And then I'm going to divide by, in parentheses, those are important if you're typing this into your calculator, everything on the bottom. Okay? Final answer comes out to be, rounded to 3 significant digits, 122 miles per hour. Boom. Next, density. You find a small chunk of silvery gray metal after smashing your smartphone. You find its mass to be 0.82 grams and its volume to be 0.35. So density is mass divided by volume. So we've got the mass, because that's in grams, divided by the volume in milliliters. And that comes out to be, rounded to 2 significant digits, 2.3, because that's 2 significant digits. 0.82 is 2 and 0.35 is 2. Units, grams over milliliters. And then let's identify it. It looks like it is silicon. Which has a higher density, an aluminum can or an aluminum paperclip? This is a trick question because no matter what, the density of aluminum is always going to be 2.69. So maybe the can is 269 grams and it's 100 milliliters. Well, grams divided by milliliters here is 2.69. And then maybe the paper clip, I'm just doing easy numbers to make it work out. Maybe the paper clip is 26.9 grams. That's really unrealistic, by the way. And then the volume is, it's a giant paper clip. The volume is 10 milliliters. Well, look, they're still going to come out to be the same density because the particles are packed the same way. So they'll be proportional. How would you round the volume, record the volume in this graduated cylinder? Okay, we got to go from the bottom of the meniscus. Oops, I'm kind of making that go higher than it is. Okay, so let's identify what these marks are. This here is 5.5. This is 5.1, 5.2, 5.3. This one is 5.4. So since it goes by the tenths place, I want to estimate and record out one more digit. So final answer, maybe 5.423. Okay, it doesn't really matter because as long as you write a digit here, that shows me that you understand how to record, how to accurately measure with the instrument that you're given. Now, let's say, just to be thorough here, there was another graduated cylinder that was cheaper that someone at a different lab table was using, and it only went by the ones place. And so here it was, here's the meniscus. You could only say for this one 5.4 because you can only round out to the tenths place since it goes by the ones place. So if you tried to say 5.42 in this case, you'd be wrong. Okay, a student measures the density of some water using the procedure we followed in class. Weigh an empty graduated cylinder, add some water, weigh it again, record the volume, and then following that procedure, they collected this data, and you are supposed to calculate the density of the water sample to the correct number of significant figures. Okay, so we need to know what is the mass of the water alone, because the mass of the graduated cylinder plus the water was 37.78, and then just the graduated cylinder alone was 13.56. So if we subtract, then we'll know how much the water was by itself. That's 24.22 grams. Okay, now we know density is mass divided by volume. So 24.22 grams divided by 25.1 milliliters. Answer 0. We got to do significant digits. This has 3, this has 4. So our answer can only have 3.965 grams per milliliter. Last one. When you look at a graph of mass versus volume, okay, and you've got mass on the y, volume on the x, you've got change in y over change in x, change in mass over change in volume, that's going to give you the density as the slope. Because we know, we've learned that change in y over change in x is equal to the slope. So it says, what's the density of fresh water based on this data? Well, fresh water is this one. This one's salt water, so we don't need to look at that. And here's the slope. So it's 0.9813 grams per milliliter. How did I use this graph to determine it? Like I said, the slope equals change in y over change in x, which is equal to mass divided by volume. Okay, hopefully that helped out a little bit.